Okay, so let's go ahead and start 4.1b. And in this one, we are going to, this is what we went over in the last video. We went over the sine and cosine curve. We talked about the period having to do with what is being multiplied in front of that x value, right? So we can find it by taking our normal period, which is a 2 pi length, and dividing it by the absolute value of b, right? And then our amplitude, which is the distance from our vertical center up to our max, right, or down to our minimum, we get by looking at what's being multiplied in front of the function. So that's the absolute value of a, right? So I really quickly just want to run through the sine and cosine curves and then give you a little bit of a something that may help you remember the shapes, okay? So for both of these, we use a period of 2 pi, right? So we're going to go out 2 pi distance. Half of 2 pi would be pi. Half of pi would be pi over 2. And then our third point, right, if we count by half pi, we have half pi, pi, 1.5 pi, or 3 pi over 2, and then 2 pi. Okay, so remember when we do the sine, we're going around that unit circle, right? We're going around the unit circle to the quadrantal angles, and we're looking at their y values. Okay, so for y, we start at 0, we go up to 1, down to 0, down to -1, and then back up to 0. So here's our 1, here's our -1. So at 0, we're at 0. At pi over 2, remember we're up at 90 degrees, up at 1. At pi, at 180, we're back over, right, on the other side, down at 0. And then at 3 pi over 2, which is our 270, right, we're all the way down at -1. And then at 2 pi, we're back up at 0. So this is what our normal sine curve looks like. Hopefully you're a better drawer than I am. Okay, these need to look as close to semicircles as we can get them. Okay, so notice here from our vertical center up to our maximum, our amplitude distance would be 1. Okay, all right, then we want to look at the graph of cosine. Cosine also has a period of 2 pi, and it also has an amplitude of 1, right? If we haven't multiplied anything on the inside or the outside, it's a 2 pi distance with an amplitude of 1, okay? And we use the same nice quadrantal angles because we still want really nice xy values, right? And this time, again, we're going to go from 1 down to -1. But if we look at our x values for cosine as we go around the circle, notice here x is 1 at 0, and then x goes to 0, x goes to -1, x goes to 0, and then x ends at 1. Okay, so we're going to go ahead and label those. So we start up at 1, then we come down to 0, then we go down to -1, we come back up to 0, and we end back up at 1. Okay, so we're going to go ahead and draw this curve best we can. So it looks something like that. Okay, so I always have something kind of silly in my head that helps me remember the shapes of things, kind of like when we had to remember the Pythagorean trig functions, like you sin, you confess you're one with God, or one cocos and stuff like that. So the same thing is true when I think about the sine curve and the cosine curve. So when I think about the sine curve, I think of sin. It just looks like sin, right? Because we write it sin. We just say sine. So when you think about the world, right? The world started off with no sin, right? Started off with no sin, and then it kind of increased, right? We started off in the Garden of Eden, everything was great, and then, Eve and her apple, right? But we start off with no sin. Everything's great, and then we kind of have the fall of man, right? So we're going to go ahead and say we start with no sin in the world, and then it increases. Right off the bat. We start with no sin, and then boom, we just start sinning right away, right? So that's how I remember it. Okay, sine starts at 0, and then it starts going up, okay? Now, if it starts at 0 and you see it starts going down, you should be thinking, oh, that's the sine curve, but it's been reflected, right? So I want you to remember sine curve starts at 0 and then starts increasing. So we start off with no sin, right? And then very quickly it starts increasing. All right, and then when I think of the cosine curve, cosine, I think of, honestly, I try to think of a word that starts with a C, right? Cosine, cos. And I thought, okay, well, that sounds kind of like cough, right? If it's a cosine curve, cos, we cough, right? Well, why do we cough? Well, we cough because we put something in our mouth, right? And it goes down our windpipe. It's not supposed to go down our windpipe, and we cough it back up, right? So think about this being your mouth, right? Here's your little Pac-Man. You put something in your mouth, right? And it goes down, headed towards your stomach, but it actually hit your windpipe, and you went and coughed it back up, right? Okay, I don't know if that helps or not, but you can think of this as coughing, cough up something, okay? Cough up something to catch, right? Because once you cough it out, you gotta catch it up here. All right, so whatever you put in your mouth, it comes down, you cough it back up. So big thing for cosine to remember is it always starts up at 1, and then it decreases. It goes down your windpipe, and then you cough it back up, right? So it's very, very important that you know everything that is on this page. Okay, this is pretty much the basis of your next test. We're going to add on to it, but we need to know the general shape of sine and cosine. We need to know the period length and the amplitude. And then what we're going to do is we're going to obviously transform it. We're going to screw with it a little bit. We're going to stretch it, shrink it, reflect it. Maybe we're going to carry it on over 2 periods in one direction or the other. Well, we can't do any of that if we're not familiar with these shapes. Okay. And again, if you can't remember the shape, always go back to relating it back to your unit circle and just following those quadrantal angles all the way around, okay? All right, so let's look at one just to refresh. It may have been a hot second since you watched the last video. So let's look at this. First thing we want to do, because we have a multiplication on the inside, is we need to adjust our x's to make sure we still land on those nice quadrantal angles. So I'm going to take whatever is inside this function, and I am going to make sure that it lands between 0 and 2 pi, because I know that cosine is normally a 2 pi period length, right? One trip around the circle. So I want to make sure I can adjust my x's so that I pick x's that will make me land on those nice quadrantal angles. So in order to get rid of this 1/2, I'm just going to multiply everything by 2. And that way when I multiply by 2 here in the middle, those cancel, right? So that means my x's need to be between 0 and 4 pi. Okay. Now that tells me that my period length from 0 to 4 pi, that's a distance of 4 pi, right? Period length is going to be 4 pi. And I can double check it by using my formula. Remember, my formula says I take 2 pi and I divide it by the absolute value of whatever number is being multiplied by that x. So the absolute value of 1/2 is just 1/2. And then when I divide by a fraction, I actually flip and multiply, right? So this is 2 pi times 2 over 1. So that gives me a 4 pi period. Okay, so indeed, my period length is now going to be from 0 to 4 pi. So I'm going to start at 0, I'm going to end at 4 pi, and I need to figure out what the 3 other tick marks are going to be on my graph. So I'm going to go ahead and go down here, and I'm going to say, okay, well, here's where 4 pi is. So halfway to 4 pi would be 2 pi, right? And then halfway from 0 to 2 pi would be pi. So we're going a pi distance at a time. So this is 1 pi, 2 pi. So my missing tick mark here is 3 pi. Okay, so here's pi, 2 pi, 3 pi. And by adjusting those x's, what I have ensured is that I can now use my regular cosine values going around the unit circle. So remember, you can either look back at this at the page we just did to see what our normal cosine is. So think about coughing. We start up at 1, go down to 0. It hits our esophagus down here at -1, starts coming back up to 0, and we cough it out back at 1. So 1, 0, -1, 0, 1. So those are the values we want to use on our chart. 1, 0, -1, 0, 1. Okay. So then we're going to go ahead and notice here, I don't have to multiply these by anything because this I took care of here. Okay, when I adjusted my x values, I took care of that. That's why I can just use these. And if you need to see the nitty-gritty of y, if I were to plug these into this function, I would end up with those quadrantal angles because 1/2 of 0 is 0. 1/2 of pi is pi over 2. 1/2 of 2 pi is pi. So it's giving me those nice quadrantal angles. Okay. All right. So now that we have our outputs, we're going to go ahead and put them on here. So this is from 1 to -1. So we start up at 1. We come down to 0. Then down to -1, back up to 0, and we end at 1. So we can see here, we get that nice cosine curve, our little cough, right? And this is over 1 period, because we found that our period length was 4 pi. Okay, so we can see here from our vertical center, right, up to our max, or from our vertical center down to our minimum, we can see that our amplitude is 1, right? And we do not have a reflection. We do not have a reflection because we know cosine starts up at 1, goes down and ends at 1. So if this had a reflection, it would start at -1 and go up, right? So we're going to say none. Okay? All right, and then what it wants us to do down here at the bottom is it wants us to go ahead and take this function that we just graphed, but it wants us to continue it over 2 period lengths. So if 1 period length is 4 pi, then if I want to continue it on out, I would have to go all the way out to 8 pi, right? Or if I go out to 4 pi, then I continue it in the negative direction. I could go to -4 pi. Okay, so whichever one we want to do. I'm going to go ahead and do both just so that we see both directions. So here we have pi, 2 pi, 3 pi, 5 pi, 6 pi, 7 pi, 8 pi. Okay, and 1, -1. So we start up at 1, go down to 0, down to -1, back up to 0, back up to 1. So here's the cosine curve we started with. And then if I want to extend it another cycle, then again, here I start up at 1, I go back down to 0, back down to -1, back up to 0, and then I end up here again at +1. Okay, so this is 2 periods, or I can extend it in the other direction, right? I could go negative pi, negative 2 pi, negative 3 pi, negative 4 pi, and then continue it on in that direction. So here, this one would come back down to 0. This would be at negative 1, 0, and then up at 1. Like this. So then this distance would be 2 periods. Okay. Again, I don't care if you want to just keep going in this direction or if you want to go in this direction. Honestly, what I find most of the time is that I think it's easier to go in the negative direction a lot of times, because whatever your units are here, you can just copy them on this side in the negative version of it, right? Anyways, but it's up to you. Okay, so what I would like for y'all to do, just to kind of refresh off the last video, is I want you to try and graph these 4 functions. So notice this is sine x, okay, right? So that's a 2 period length. And then it wants you to flip sine x over the x-axis to get the graph of negative sine x. Okay, so you should know the shape of sine, right? You sin, or there's no sin when we start out, and then it quickly increases, right? And then flip it to get the negative sine function. And then I want you to do the same thing with cosine and negative cosine. Okay, if you're not sure on the negatives, at least take this time to try and fill in the sine function and the cosine function. Those are ones that we need to be super familiar with. We need to know what our nice radian measures are and what our y values or our x values are at those radian measures. Okay, so go ahead and pause the video and then we'll go over it here in just a little bit, okay? Okay, so let's see how you did. So sine, remember, starts at 0 because we start off with no sin, right? And then it goes up to 1, comes back down to 0, and then down to negative 1, and then we end at 0. So a full sine curve looks something like this. Oops, and I missed 2 of my points. Okay, so what I'm going to do is I'm actually going to go ahead and just label these points. This is the point 0, 0. This is the point pi over 2, 1. This is the point pi 0. This is the point 3 pi over 2, negative 1. And this is the point 2 pi 0, right? So on this next one, it says flip y equals sine x over the x-axis. In other words, what we want to do is flip this, right? And this gives us the graph of y equals negative sine x. Now, when you see this negative, basically all we're doing is negating the y values. Oops, y values. So if I were to take these points and change their y values, so 0, 0 would still be 0, 0, right? 0, 0. On this one, if I negate this y value, instead of being pi over 2, 1, it would be pi over 2, negative 1, right? If I negate 0 here, instead of pi 0, well, it would still be pi 0, right? 3 pi over 2, negative 1, if I change the y value, now it's going to be 3 pi over 2, positive 1. And then pi over 2, 0, when I negate 0, still just is 2 pi 0, not pi over 2. Okay, so all I did was change the y values, and notice what that does is it flips my sine curve, right? Notice all the points that were at 0 are exactly the same. It's just the one that was at 1 is now at negative 1, and the one that was at negative 1 is now at positive 1. Okay? And then we want to do the same thing for the cosine. Okay? So if I look at the cosine curve, we know cosine starts up at 1, then goes down to 0, down to negative 1, back up to 0, back up to positive 1. So this curve looks something like this, right? So then if I want to take it and I want to negate the y values, again, right? Negating the y values. Then notice when I negate this, the ones that have zeros, those aren't going to change, right? Those are still going to be at 0. Because if I change 0 to -0, that's still 0, right? But the one that's up here at +1 is now going to be at -1. The one that's down here at -1 is now going to be up at +1. And then my last one that's up at 1 is now going to be down at -1. Okay. So putting that negative in front of the cosine, whoops, I missed that one, in front of the cosine curve flips it around the x-axis. Okay. So these are good graphs. Definitely 100% you need to know these two graphs of sine and cosine. Okay, but we also need to not necessarily memorize the points, but just recognize the shape. If I see a shape that looks like this, I should be able to look at that and say, oh, that's a sine curve, because I can see it starts at 0, but because it didn't go up, that means it has a reflection. Okay, same thing with the cosine one down here. I maybe don't have all the points memorized, but I should be able to say, oh, this is a cosine because it didn't start at 0. It started at -1. Now, cosine normally starts at +1, so this one must have had a reflection, okay? Just a few things to be able to kind of point out, okay? All right, so let's go ahead, and I want to do an example. And then I'm going to have y'all try one. Okay. So it says graph y equals -3 sine 2x over 1 period. Okay. So remember, this number out here is my A. This number in here is my B. Okay. Before I do anything, I notice if I am multiplying by anything on the inside, I want to go ahead and take that and adjust my x values so that I get good quadrantal answers or values, right? So I'm going to go ahead and start between 0 and 2 pi is where I want my whatever's inside this function, which in this case is 2x, to fall between 0 and 2 pi. So to get rid of that 2, to get x by itself, I'm going to divide everything by 2. So that tells me that my x's need to be between 0 and pi. Okay, so I'm going to put my first x as 0 and my last x as pi, and I'll fill those in just a second. I'm going to go ahead and fill out my period. Excuse me. My period I find by doing 2 pi over the absolute value of b. So in this case, I'm going to do 2 pi over, my b in here is a +2. So 2 pi divided by 2 is just pi. Okay, so that's a good way to check yourself. Notice here I got a distance from 0 to pi, and my period length happens to be pi. So I know I did it right. My amplitude is the absolute value of whatever I'm multiplying by outside my function. So the absolute value of a, which in this case is the absolute value of -3, which is just 3. So that means from my vertical center, I should be going up 3 to get to my maximum or down 3 to get to my minimum. Okay, and then do I have a reflection? Well, yes, I should have a reflection because I see that negative out front. So I'm going to go ahead and say yes. And the way that I know is that we are negating the y's, right? Because we have that negative outside the function, which means it's going to flip about the x-axis. Okay? All right, so I have everything I need to know. Now let's go ahead and graph it. I know that 1 period length goes out to pi. So half of that length would be pi over 2. So half of that length would be pi over 4. right? So I'm counting by pi's over 4. 1 pi over 4, 2 pi over 4. My next one is going to be 3 pi over 4, right? So I'm going to go ahead and label these pi over 4, pi over 2, 3 pi over 4. Okay. Now we've already adjusted these x's so that we'll get those nice quadrantal values. So I need the quadrantal values for my sine function. Remember, sine starts at 0. So I'm going to start at 0, then go up to 1, back down to 0, all the way down to -1, and then I end at 0. Sine starts and ends at 0, right? All right, so I've adjusted my x's to get my nice quadrantal values. Now I have to do is adjust my y's for whatever is out front of my function. So I'm going to do -3 times 0, -3 times 1, -3 times 0, -3 times -1, and -3 times 0 to see what my y values are. Okay. Again, you're probably able to do this in your head. I'm just writing it down, so if you look back at your notes, you're not thinking, how did I get that, right? All right, so here we're going to get 0, -3, 0, +3, 0. So these are the y values for this function. So I'm going to go ahead and write it way up here. I'm going to say this is 3, and down here is -3. Okay. So this function starts at 0, 0. And then we go to pi over 4 down at -3, pi over 2 back up at 0, 3 pi over 4 back up at +3, and pi we're back down at 0. So this one should look something like this. Okay, and it said to graph it over 1 period length, so I don't have to extend it. And then I just want to double check that everything's right. So notice I was able to graph the full cycle in a pi distance. My amplitude from my vertical center up to my maximum is indeed a distance of 3. And I can tell that yes, there is a reflection because my sine curve normally starts at 0 and goes up. And here it's at 0 and it's going down, okay? All right, so this is the process that you need to be familiar with when you're graphing these problems. So this is what I want to see when you work through your worksheet. I want to see that you adjusted your x values if there's something other than just x inside, okay? I want to see that you calculated your period, your amplitude, and tell me if there is a reflection, yes or no. And then adjust any other, put your nice quadrantal angles and then adjust for your y and then graph, okay? So I want y'all to try the whole process on page 5, okay? So here we have the same type of thing. This is your A, this is your B. So I'm going to leave y'all to do it. Adjust your x's so we get nice quadrantal values and then adjust for your y. Don't forget to find your period and your amplitude. And then when you feel like you're ready or if you get stuck, unpause it and we'll go over it, okay? Okay, let's see how you did. So first thing I want to do, because I noticed that we're multiplying by something inside this function, is I want to adjust my x's to make sure I can use these nice quadrantal angles. So I'm going to take whatever is inside this cosine function and I'm going to put it between 0 and 2 pi to ensure that I get that whole cosine cycle, right, the whole cosine curve, but that I adjust it so that I have those nice quadrantal angles. So I'm putting pi over 2x between 0 and 2 pi, and I got rid of the pi over 2 in 2 steps. First, I multiplied everything by 2 to cancel out this 2. So that gave me 0 is less than or equal to pi x is less than or equal to 4 pi. And then I divided off the pi because all I want in the middle is x because I'm trying to figure out what to put over here. So this says that my x's need to be broken up into 4 equal parts between 0 and 4. So I went ahead and put 0 and 4. And on my graph, if I go from 0 to 4, half of that is 2 half of that is 1. So I know I'm just going by 1. So I filled in all my points as being 0, 1, 2, 3, 4. Okay, and you can double check yourself to see that when you plug in 0, 1, 2, 3, 4 into this function inside here, that it does in fact end up simplifying to those 5 quadrantal angles. Okay, all right, so I went ahead and put my quadrantal values in here. Cosine we know starts up, right? Cough. So it starts up at 1, goes down to 0, down to -1, back up to 0, and then ends, up at 1, right? So just to double check that I did this 0 to 4 period correctly, I'm going to go ahead and calculate my period by doing 2 pi over the absolute value of b. So remember, b is what I multiply in front of that x. So 2 pi over the absolute value of pi over 2, which is just pi over 2. And then if I flip and multiply by the reciprocal, then I do in fact get 4. Okay. My amplitude should be 5 because remember we just do the absolute value of whatever that a value is being multiplied in the front of the function. And here I don't have a reflection because I don't see a negative on the inside or outside of my function. Okay. All right. So now that I know I'm going from 0 to 4, I have my quadrantal values for cosine, and then all I have to do is adjust for anything being done to the y's. So remember, this means 5 times that cosine value. So I just multiply all my cosine values by 5, and that gives me my new output. So you can see at 0, I'm up at 5, 1, I'm back at 0, 2, I'm down at -5, 3, I'm back up at, that should be a 0, not a 5. And then 4, I'm back up at 5. So I do in fact get my nice cosine curve here, and I hope you did as well. Okay. All right, so I have one more little thing to show you, and that will be the end of section 4.1. And the last thing I want to show you is instead of us being given a function and we determine the period, the amplitude, and all this stuff and graph it, we're going to go the opposite direction. They're going to give us a graph, and we're going to see if just by looking at the graph, if we can figure out if there's a reflection, if we can figure out the amplitude, if we can figure out the period, and then if we can use all that information to actually write the function that represents this picture. Okay, so that's where we're headed. So let's look at page 6. All right. So it says start with a graph and find the formula. So when it says find formula, that means we're looking for either y is equal to a sine of bx or y is equal to a cosine of bx. Okay, this is the formula we're looking for. We're looking for that equation that represents this picture. Okay. So it says determine the formula for the graph given. Now, the first thing that I want to look at is I want to see, do I think this is a cosine or a sine curve? Okay, so remember, sine starts at 0, cosine is the cough that starts up at 1. So when I look at this, I'm looking to see, does my curve start at 0 or does it start up or down at some other value? And this one, notice, starts up. So since this one starts up, I'm going to assume that it's a cosine. Okay. So first thing we're going to do for our function is we're going to look at the y-intercept. Okay. Look at that maximum value or the minimum value, whatever it happens to be. And if it starts at 0, we know it's sine. If it doesn't start at 0, then it's a cosine function. So I already know we're going to be looking for something that looks like y is equal to a cosine of bx. Okay, we know it's a cosine function. Now I want to look and see the period. So remember, the period is how long it takes to make one cosine cycle, one little cosine curve. So this has obviously more than one. It's making a W. So remember, a cosine curve starts up, it goes down, and then it ends back up. So that's one cosine curve. So if I look at just this piece right here, right? I don't know why I drew it out there. I was just kidding. So if I look at just this piece, this is one cosine cycle, right? So the period length that it took to do that one cycle was from 0 over to pi. So that means that my period length should be pi. Okay? Now, why I need to use that is because period length, remember, relates to this b value that's inside here. Okay? Right? This has to do with amplitude. This has to do with period length. Okay? So if I know my period length, I should be able to use its relationship to this b to figure out what b is. So remember, when we were given the function, the way that we determined our period length is we calculated 2 pi over the absolute value of b, right? So we can use that. We can say, okay, well, 2 pi over b gives us our period length. We know that our period length is pi, right? So we just set 2 pi over b equal to pi, and then we can solve. So we cross multiply here, which gives us 2 pi equals b pi. And then if we divide pi off of each side, we end up with b is equal to 2, right? So we know that our b value is 2. So I'm going to go ahead and just put an arrow. We now know that this is 2. So the last thing we have to figure out is what is our a value. So our a value is our amplitude. So let's go back to our function. And remember, our amplitude is the distance from the vertical center, right? The vertical center of this function up to the maximum point or down to the minimum point. So notice my maximum is 2, my minimum is -2. So from that vertical center up to the maximum, that's a distance of 2. Okay, so I know that my a value is 2. I know that my b value is 2. And the last thing I have to determine is, has this been flipped? Is this a normal cosine curve, or has it had a reflection? Okay, so remember, a normal cosine curve starts up high. We swallow something, we cough it up. So this one has not been flipped. Okay, so we're going to say no. So we don't need a negative out front. So now we can just put in everything that we have found. So we know that y is equal to our a value, which we know is 2, times the cosine of our b value, which again is 2, times x. So this is the equation that represents this picture, okay? And they just graphed it over a 2-period interval, okay? So notice we're going through kind of the same process, right? We're just getting everything off the picture. Based on the shape, we should be able to decide if it's sine or cosine. Based on its amplitude, we should be able to determine a. And then just by looking at it, we should be able to determine the period length. And then by taking that period length and setting it equal to 2 pi over b, we should be able to solve for our b value. Okay? If it's flipped, we would need a negative in front here. In this case, it was not flipped, so we didn't put a negative. Okay? All right, so I want y'all to try one like this. On the next page, there's one very similar. So I want you to go through the same process. If you have to, you can use the same little strategy that we had written for us on the next page. So the first thing, I'll even write it here. So the first thing is we want to determine the function. We want to know, is it cosine or sine? Then the second thing, we need to find the period. And then the third thing, we need to find the amplitude. Then the fourth thing is we want to know, is it flipped? And then the last thing is we write our equation. Okay, so I'm going to go ahead and let you pause it so that you can give that one a try. And then when you are ready, or if you get stuck, let me know and we'll go over it, okay? All right, so let's go ahead and look at this one. The first thing that I notice is that it's starting at 0. So if it's starting at 0, I can go ahead and say that that has to be a sine function, right? And then I want to find my period. So my period length is 2 pi over b, right? And I can see that that distance here, in order to complete one sine curve, I start at 0, I'm going down and up, and then I'm ending at 0, right? So this is one full cycle, and that's stopping right here at pi. So from 0 to pi means my period length is a length of pi. So I'm going to set 2 pi over b equal to pi, right? And then I just solve. So I cross multiply, which gives me 2 pi equals b pi. I divide both sides by pi, which gives me 2 is my b value. Okay, so I'm a little bit closer. Then I need to know my amplitude. So I look from my vertical center up to my maximum value, and I can see that's a distance of 2, right? Or if you look to your minimum value, same thing. We're taking the distance, so make sure you take the absolute value of it. So our amplitude is 2. And then we need to determine, has this been flipped? And obviously here it has, because sine normally starts at 0, right? 0 sin, and then it increases. So the fact here that it starts at 0 and decreases, we know that yes, it has been flipped, which tells me that we're going to use a negative amplitude, right? Or my number out front is going to be negative. So my equation is going to look like y equals a sine bx. A is going to be 2, but since it's flipped, we make it negative. Sine of, and we found that our b value inside the function was 2. So we should have ended up with y equals negative 2 sine of 2x. Okay? All right, I want to show you just one more like this, and then we're done. Okay? You can get started on 4.1. All right. So here we go. This one's a little bit different. I'm going to go ahead and write our strategy over here. Let's put our function, our period, our amplitude. Is it flipped? And then what's our equation? Okay. All right. So if I look at this, the first thing that I notice is that it does not start at 0. Right? If it started at 0 and went up, or started at 0 and went down, we'd know it's a sine function. But here it's starting up at 3, which tells me that this is going to be a cosine function. Okay? So we should be looking for y is equal to a cosine bx. Okay? So now we're going to look for our period. Well, we know that a cosine curve starts up high, it comes all the way down low, and then it continues on up high, right? So notice what's happening here is we don't have a full cycle, right? We have it coming down low, but then it should also, continue and do something like that, right? So what we have from here to here is only half of the period, right? So if half of the period is equal to 2 pi, right, because that's this distance right here, then a full period, right, a full period would be a distance of what? Well, it would have to be double that, right? So a full period would have to be 4 pi, okay? So now I know how far the period length is. I can go ahead and set that equal to our formula. So our period formula says to do 2 pi divided by b to get our period length, which we know is 4 pi. And now I can go ahead and just cross multiply. So when I cross multiply, that's going to give me 2 pi is equal to 4 pi b, right? And again, I'm solving for b. So I'm going to go ahead and divide off the 4 pi. And so that tells me that b is equal to, when I reduce here, my pi's will cancel, and I'll get 1/2. Okay. So now I know my b value is 1/2. Now I need to find my amplitude. So I go from my vertical center. So here is where my vertical center is, right, of this one. And I can see that up to my max, right, or down to my minimum, that is a distance of 3. So my amplitude is a 3. I want to see if it has, so that's my A value, right? And I want to see if it has been flipped, right? Well, cosine normally starts up high and then comes down and we cough it out, right? So because it's starting up high and then going down low, it has not been flipped, okay? So that means my equation ends up being my amplitude, which is 3 times cosine of my b, which is 1/2 x. Okay, and we should just leave it like that. Okay. All right, so that is the end of section 4.1. So you should now be able to complete that homework assignment as well as the worksheet. All right, let me know if you have any issues.